What happens is
the qubits of the Google quantum computer are making a little bit of extra space, and that's our wormhole.
a pulse of negative energy falls into the wormhole.
Now the wormhole becomes traversable. It opens.
You put a qubit through one side of the wormhole.
The qubit is now in the interior of this wormhole.
That information will actually spread over the entire quantum system. This spread of quantum information,
It becomes shared by many particles in the form of quantum entanglement. And then, rather remarkably,
it has to refocus as a single qubit. And then, as the wormhole is closing, the qubit is exiting.
I was absolutely astounded.
The vector is pointing right from the experimental point of view.
This is a confirmation, a direct exploration of this connection between quantum entanglement on the one hand and the way space is knit together and holds itself together.
As Google builds more and more capable quantum computers, we will eventually be able to get this into a regime where we don't even know how to predict what's going to happen. And I think we're going to have hundreds of my fellow physicists now writing papers about all the other things you can think about doing now that we've sort of got this door a little bit open.
and as always in physics, when you are able to explore a new frontier, there will be discoveries that weren't anticipated. Just like when you build a more powerful accelerator to study particle collisions or a more powerful telescope to look at the more distant universe, a more powerful quantum computer will be able to study highly entangled matter that we've never been able to look at before.
I think in the next 20 years, there are going to be a lot of fun for fundamental physics. Being very close with quantum, we're going to learn a lot.
There's so many questions that one could explore using these ideas. And I think most exciting are the questions that we can't yet pose.